Okay, how you guys doing there? Hopefully well. Hopefully you had a Merry Christmas and having a Happy New Year so far and ready to get back to doing some schoolwork, doing some math at least. Hopefully we'll see you guys back in the classroom here on the 19th of January, but until then we're still virtual, so if we're not back on the 19th, hopefully it'll be soon after and things can start getting back to normal, I'm hoping. A couple things before we start. We are starting a new semester here. We're starting Chapter 4, Section 4-1 today. I'm making this video actually on December 30th or so. This assignment, we're not going to start it until January 4th on Monday. And it's due on Wednesday, the 6th. So you'll have all of Monday, Tuesday, and Wednesday to work on the assignment. First off, though, it's so important that you check your email regularly, okay? At least once a day. If I'm sending you an email, it's because I have something important I need to tell you, okay? Actually, this is not your first assignment that we're getting ready to do here, Section 4.1. Your first assignment came to you over the last few days or so as an email, okay? I'm sending everybody an email. It might actually be today. I'm not sure exactly when, but in an email that explains how this semester is going to be a little bit different than last semester in terms of doing your homework and so forth. One thing that you need to know that by reading that email and responding to it is you'll know that you will not be able to do Section 4-1 until you respond to that email. I'm not going to assign, once you respond to the email that I sent you, I will activate Section 4-1 for you, and you will be able to do your assignment then. But until you respond to that email, you will not be able to do Section 4-1. Okay, that'll be the only assignment I do that for. From that point forward, when I cover an assignment, you'll already have the assignment activated to be able to do Section 4, whatever the next section is, okay, Section 4-2. So anyhow, make sure, like I say, check your emails regularly. That is so important, okay? All right, so we're starting Section 4-1. And we're going to go over a few things. And this is going to start out really, really simple, I think. And then it's going to get kind of confusing near the end, but hopefully it won't be too bad. So we're talking about polynomials, okay? And if you're wondering, polynomials, what's that? You've been dealing with polynomials the entire semester, plus all of algebra, regular algebra, not just algebra 2. You've dealt with polynomials. The prefix poly means several, more than one, like polygon, a shape with several sides, okay? So anyhow, polygon just means many terms, okay? So I'm going to go over a few notes. Then we'll actually start the assignment. The assignment itself is really not that bad. Okay, so an example of polynomial would be, and you don't really need to take notes on this, you can just watch. Polynomial, an example would be 3x to the fourth minus 2x squared plus 9. That's a polynomial. There's three terms there. Terms are separated by plus and minus signs, okay? If I was to give you negative 8x to the seventh plus 5x to the third minus 2x squared plus 4x minus 11. That's a polynomial with 1, 2, 3, 4, 5 terms, okay? So those are polynomials, okay? Now, we talk about the degree of a polynomial. The degree of this polynomial would be fourth degree. The degree of this polynomial would be seventh degree. Degree is quite simply the highest exponent, okay? Whatever the highest exponent is, that's the degree, okay? So, what else do we need to talk about in this? Oh, they talk about putting a polynomial in standard order. The order is determined by the exponents. Exponents need to go from biggest to small. So these are both in standard form. 7, 3, 2, x to the first, and then we have 11 at the end, okay? So you always have them going in descending order of exponents. So if I was to give you 9x minus 3x to the fourth plus 2 minus 8x squared, okay? That would be fourth degree, but it's not in standard form. Standard form, this term should have been first, but watch the negative, so negative 3x to the fourth. The next highest exponent is negative 8x squared, then positive 9x, and then positive 2. That's in standard form. That would be fourth degree. Now, they also ask us for we need some terminology. There's certain names for some of these things. If I was to give you the degree and the name for it, degree 0, okay, is a constant, okay? And a constant is just a number. Like, for example, 8. That's degree 0. Now I'm thinking, well, the exponent's a 1. It's the exponent on the variable. There is no variable. So that would be degree 0 is a constant. Or negative 12. That's a constant. Degree 1 is linear. Okay? 3x minus 7. Like y equals 3x minus 7. That's a line. That's why it's called linear, because it's to the first. Second degree, you should know by now, is a quadratic. Okay? Example, if this was That would be a quadratic now. Second degree is a quadratic. Third degree are called cubic. If the highest exponent is 3, it's a cubic. So I went like this. This would now be a cubic. Fourth degree are quartic. Fifth degree are called quintic. After that, I'm not sure. Okay, what do I call sixth degree? I call it sixth degree. I'm sure there's a name for it. I don't really care. You need to know all the way through fourth degree is called a quartic, okay? So make sure you have those memorized. Okay, you should have linear and quadratic memorized. Cubic's easy. It's raised to the third power. You're cubing something. That's not bad. Quartic, quarters, 4 quarters. Okay, that shouldn't be that bad. And a constant means it doesn't change. It's just a number. Okay, that's the easier part of this section. Okay, the tougher part is they talk about something called the end behavior. Actually, I'll tell you what. Let's deal with that when we come to those problems. Okay, let's start the assignment. Then we're going to, when it gets near the end, that's where it gets a little more difficult. Let's knock the easy stuff out of here fast, and then we'll get into the tougher stuff a little bit later, okay? So let's look on 4-1, exercise number 3. Let's do the easy stuff. Okay, and they give us, decide whether this, whether it's a polynomial function, okay? Actually, before we do that, I do want to talk about I'm going to give you some examples of things that are not polynomial functions, okay? If I gave you 3x to the 4th minus 4x to the negative 2nd plus 1. That is not a polynomial. And the reason is it can't be raised to a negative power. That's not a polynomial. If I gave you 5x to the 3rd plus 4x squared minus 9x to the half plus 11. That is also not a polynomial. It can't be raised to a fractional power. Okay, the powers have to be positive and they can't be fractions. Okay, or if I gave you this, 8x to the 4th minus 9x to the 3rd plus 2 over x plus 7. That is not a polynomial because it can't have x on the bottom, okay? You can have x on top. If it was x over 2, that's actually okay because x over 2 is the same as 1/2 x. So things that make things not be polynomials is it can't have negative exponents, it can't have fractional exponents, you can't have x on bottom. I think that's probably all you'll need to worry about in this section, okay? So I mean, if I give you something like this, y equals 3 sine x minus 9. Remember, what the heck is sine? You don't need to worry about that right now. You worry about that when you take trigonometry. That is not a polynomial, though, okay? It's a trig function. And we're not in trig right now, so you don't need to worry about that, okay? But for this class, as long as you understand, as long as the exponents are not negative, they're not fractions, and x isn't on bottom, it's a polynomial, okay? All right, so let's look at question number 3 now. So they give us f of x is negative 3x. 3x plus 5x3 minus 6 something minus 6x squared plus 2. Okay, this is a polynomial, okay, because there's no fractional exponents, there's no negative exponents, x isn't on bottom, so we're good. So it is a polynomial, and they want it in the correct order. So the exponent is 5x to the 3rd should be first, then negative 6x squared, that's next highest, then minus 3x, and then plus 2. That's the standard form. It's a polynomial. It is in standard form. Okay? Do they ask us for the degree? No, they don't. No, just leave it like that. Oh, yes, they do ask us underneath that. Okay, so the degree of this is degree 3, which is called a cubic. And what else did I ask us? And the lead coefficient. I didn't talk about the lead coefficient. The lead coefficient is the very first number if it's written in the right order. The very first number was negative 3, but it was in the wrong order. In the right order, 5 is the lead coefficient, okay? Now, if you're wondering what's the big deal, who cares what the lead coefficient is? When we get into the harder stuff, the degree and the lead coefficient are going to make a big, it's going to be very important, okay? So we'll deal with that in a little bit. Let's look at number 5. Okay, so number 5, they have f of x is what? 9x4 plus 8x3, 9x4 plus 8x3. Minus 6x negative 2. Then what? Plus 2x. Okay, this is not a polynomial. We have a negative exponent, okay? So it's not a polynomial. And how do we answer the rest of the questions? It says write in your instructions on your computer. Just leave it blank. Don't type in anything else, okay? Don't put in the degree or the type or the lead coefficient. Just leave it blank. You click on not a polynomial and you move on. Okay? Number 7. Okay, so we have h of x is 5/3 x squared minus radical 7 x to the fourth. Plus 8x3 minus something. Minus a half plus x. Plus x. Okay, that is a polynomial. You might be thrown by this radical right here, but that's okay. If you had radicals for the exponents, that'd make it not be a polynomial either, but this is a polynomial. Okay, and let's put it in the right order. This has the highest exponent, so negative radical 7 x to the fourth. That looks terrible. Negative radical 7 x to the fourth plus 8x3 plus 5/3 x squared plus x minus a half. Okay, so that's the order it should have been in. It is fourth degree. That's the highest exponent, is fourth degree. And that is called a quartic. And the lead coefficient is negative radical 7. Okay? Okay, on number 9. Okay. Question number 9, they made a mistake. I mean, the problem, they made a mistake. It's your job to find out what the mistake is. Okay? So, what does number 9 say? They give us f of x is 8x3 minus something. 7x4 minus 9x. Sin x minus 3x squared plus 11. Minus 3x squared plus 11. Okay. And they tell us, it says, f is a polynomial function. Well, that is a polynomial function. So far, so good. The degree is 3. Degree is 3. That's wrong. Okay. This is the first exponent, but it's not written in the right order. It should have been negative 7x4 first, then positive 8x3, then minus 3x squared, then negative 9x, then 11, okay? The degree is not 3, the degree is 4. Okay? And it wouldn't be a cubic function, it would be a quartic function. Okay? And the lead coefficient is not 8. It's the lead number if it's written in the right order. If it's written in the right order, negative 7 is the lead coefficient. Okay? Okay, and then you can figure out the answers when you look at it on the computer now. Okay, number 11. You might need a calculator for these ones. Okay, they give us a function, and they ask us to evaluate it for a given value. Okay, so we have, it says h of x, but f of x, it doesn't matter, but h of x is negative 3x4 plus 2x3 minus 12x minus 6. Minus 12x minus 6. And they ask us to find when x is negative 2. Find out the value when x is negative 2. So we simply plug in negative 2. Okay, we're plugging in negative 2 for all these x's. So negative 3, when you plug it in, put it in parentheses. Negative 2 to the fourth plus 2, negative 2 cubed minus 12, negative 2 minus 6. Why are we plugging in negative 2? Nothing special about it, just what they told us to. They told us to plug in negative 2, so we plug in negative 2 for each of these values. Now, do we times, do powers first? We do powers. Negative 2 to the fourth means negative 2 times negative 2 times negative 2 times negative 2. 4 negatives are a positive. 2 times 2 times 2 times 2 is 8, or not 8, 16, I'm sorry. 2 times 2 is 4, times 2 is 8, times 2 is 16. So negative 3 times positive 16 plus 2 times negative 2 to the third, negative 2 times negative 2 times negative 2 is negative 8. Okay, so we did all our powers, now we're going to multiply. Negative 3 times 16 is negative 48. 2 times negative 8 is negative 16. Negative 12 times negative 2 is positive 24. Minus 6. Negative 48 minus 16 more is negative 64. Negative 64 and a positive 24 is negative 40. Minus 6 more is negative 46. Okay, so you're just plugging stuff in and simplifying. Okay, skip number 12 on to number 13. 13. The function they give us this time is g of x is x to the 6. Minus 64x4. Plus x squared minus 7x. Plus x squared minus 7x. 7x minus 51. X is 8 or negative 8? X equals 8. Okay, x equals 8. Okay, so let's plug in 8. So 8 to the 6th minus 64, 8 to the 4th, plus 8 squared minus 7 times 8 minus 51. I just plugged in 8 here, 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 and here, okay? 8 to the 6th, I'll tell you what, I do not know what that is. So give me a second here, I got a calculator. 8 to the 6th, and that's not 48, it's not 8 times 6, it's 8 times 8 times 8 times 8 times 8 times 8. So 8 to the 6th, ooh, big number, 262, 144. Minus 64 times 8 to the 4th is 4096, plus 8 squared is 64, 7 times 8 is 56, minus 51. Okay, so we have 262, 144 minus 64 times 4096, 262, 144. Well, that's nice. This isn't bad at all. This, take away this, that's the same number. They're gone. 64 minus 56 is 8. 8 minus 51 is negative 43. Man, that turned out nice. Negative 43. Okay, 15. So what do they give us on 15? Another function. And they give us p of x is 2x to the third. And what? Plus 4x squared plus 6x. Plus 4x squared plus 6x. 6x plus 7. And they give us what? 1/2? 1/2. X is 1/2. Okay, so we have 2 times 1/2 cubed plus 4 times 1/2 squared plus 6 times 1/2 plus 7. We just plugged in half everywhere. So 1/2 to the third, 1/2 times 1/2 times 1/2, 1/2 times 1/2 times 1/2, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. 4 times 1/2 squared, 1/2 times 1/2 is 1/4. 6 times 1/2 is 3, 7. 2 times 1/8 is 2/8, which is 1/4. 4 times 1/4 is 4/4, which is 1. 7 and 3 is 10, and 1 is 11. Plus a fourth is 11 and 1/4. I don't know if the computer's going to take that. What does that have here? It may take that. I'm going to write that as an improper fraction. 4 times 11 is 44, plus 1 is 45. I know the computer will take 45/4. Okay? All right. Number 17. Okay, now we're on to end behavior. We're almost done. Okay. But we need to talk about end behavior. All right. Some notes. You might want to jot this down. Okay? I would have suggested you jot down, linear, quadratic, quartic, and cubic, and all that. This is something else that I would encourage you to jot down, okay? End behavior, okay? The example I use is this, okay? If you worked at, say you worked at cash register, and you had to count up, let's say somebody took your cash register and dumped out all the money, all the bills, all the change, everything, and they gave you 30 seconds to get the best estimate on how much money was in there. You only had 30 seconds, and it's a lot of money, okay? Probably the best way you would want to count it is you probably add up all your 20s and 10s and 5s first. You wouldn't have time to add up everything, okay? But if you added up all your 20s, 10s, and 5s, you'd probably have a pretty good idea of about how much money is in the register, okay? If you counted up all your pennies, you wouldn't have that much time, okay? And you wouldn't have a very good idea of how much money would be in there, okay? So what you want to do is the big bills, all the money impacts the amount of money that's in the drawer, but the 20s and the 10s and the 5s, that has the biggest impact, okay, on how much money they have in the drawer, okay? So what you need to understand is this. If I was to give you a polynomial such as this, 3x to the 7th minus 9x to the 4th plus 8x to the 3rd minus 6x squared plus 4x minus 11, okay? There's 1, 2, 3, 4, 5, 6 terms, okay? Now, as I plug in values for x, this function is going to change, okay? It's going to change. The one that has the biggest impact on it, though, is the one that has the highest exponent. That's the one that has the biggest impact on it, okay? Is the lead term, the lead coefficient, and the degree on it, okay? So just like with the cash register, it's the 20s that make the biggest impact. You don't want to add up all the 20s first, okay? Not to say the other stuff isn't as important, but that makes the biggest impact on how much money is in the drawers, in the 20s, okay? So you want to look at the first term. We're going to give you some polynomials, and the end behavior means what happens to a function in the end, okay? So, I mean, if I give you a function such as this, okay? If I gave you this, okay? The end behavior, well, I mean, this goes up and down and up and down and up, down, up, down, up, and then it goes up forever. This goes up forever. So as you go to the right, this goes up forever. As I go to the left, I mean, it goes down and up and down and up, then eventually gets to a point where it's going to go down forever. Okay, it's going to go down forever. All right? So, here's what we're going to do. Okay, the end behavior here is you go to the right, it goes up forever. As you go to the left, it goes down forever. And we're going to say that mathematically, not in everyday language. Okay? So, what we need to understand is this. When I give you a polynomial in standard form, we're only going to look at the first term. That's all we're going to look at. Just like those are like our $20 bills. Okay? We're going to look just at the first term because that's one that has the biggest impact on the graph. Okay, is the first term. So we're looking at our lead term. Okay? If the lead term has a even degree, if it's like 7x to the 6th, or 8x to the 10th, or negative 11x to the 12th, those have an even power, okay? Those have an even power. If it has an even degree, okay, and if the lead coefficient could be positive, okay? It's an even degree and the lead coefficient is positive, it's generally going to look like this. Generally, not a parabola, not exactly a parabola, okay? But what I mean is this. If your lead coefficient is positive, it's going to go up, okay? So, what I mean is, if I went like this, in the big scheme of things, okay, if I was to say, what does that thing look like? It generally looks like a parabola. If I cover this up, you'd say, well, that's basically a parabola. That's a parabola, okay, except for this weird part in the middle, okay? It generally looks like a parabola, okay? So, if it's an even degree, this is only the first term, and the lead coefficient is positive, it's going to look like a parabola opening upward. But if it's an even degree, and your lead coefficient is negative, well, what that's going to look like, that's going to look like a parabola going down, basically a parabola going down, okay, for the most part, okay? Now, what if it's an odd degree? And it could be an odd degree of the lead coefficient positive, or odd degree, lead coefficient negative. These are the four possibilities. Okay? Well, if it's an odd degree, and your lead coefficient is positive, it's generally going to be going up. It's going to look sort of like this. Okay? Here, as you go to the right, it's going up, and as you go to the left, it's going down. That's if its lead coefficient is positive. It's generally going up because your lead coefficient is positive. If it's an odd degree, lead coefficient is negative, it's going to go sort of like this. And again, it's not going to look exactly like that. It might look like this. Okay? That doesn't look like a parabola. A parabola will either both go up or both go down. Okay? If it's an odd degree, one goes up, the other goes down. Okay? This right here, this generally looks kind of like that. Not exactly, but very similar. Okay? Left goes down, right goes up. Left goes down, right goes up. Okay? All right. Now we got to write this mathematically. Okay? I'm going to write this in words. Okay? I want to make sure I do this the way I don't want to confuse people here. They give us what? As we go up, let's do this. Okay, I'm going to say this. I'm going to say it one way and write it the other way. As I go to the right, we go up. Or I could say as we go up, we go to the right. Okay? Now, as we go left, we also go up. Or I could say as I go up, we go to the left also. Okay? All right? It's this right here. As I go to the right, we go down. Or I could say as we go down, we go right. Now you're wondering, why am I reversing those? Because that's the way the computer does it. I wish they wouldn't. I really wish. To me, it makes it more confusing. Okay? But same thing here. As I go to the left, I go down. Or I could say as I go down, I also go to the left. Okay? This one, as I go to the right, I go up, or I go up as I go to the right. As I go to the left, I go down. Or as I go down, I go to the left. Go down as I go to the left. Okay? Here, as I go to the right, I go down. So I go down as I go right. As I go to the left, I go up. Or I go up as I go left. Okay? Now, if it was me, before you go any further, I would maybe watch this 2 or 3 times until you have this down here, okay? Because now we're going to get to the more confusing part. We need to write this mathematically. We wrote it in everyday language. We got to write it mathematically, okay? Up and down is all y. So, no y's here. Y, 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 y. Okay? So we go up. Up how far? Up forever. So y goes to infinity. That's the infinity symbol. Y, arrow, infinity. So we go up, y, arrow, infinity. So we go down, down forever. That's not infinity, that's negative infinity. Go down, negative infinity. Okay? Go up, infinity. Go down, negative infinity. Go down, negative infinity. Go up, positive infinity. Okay? So, one more thing. Computer doesn't want you using y's. They want you using f of x. So I'm going to write f of x to infinity. Change all of these y's to f of x. I told you this section was going to start out really easy, then get a little bit tougher. Good news is there's not a ton of questions on this. Okay? Okay. All right, and then put commas after these. Now the good news is the other parts are left and right. That's just x. X goes to something. Okay, as we go to the right forever, that's positive infinity. Left, left forever, that's negative infinity. Right, positive infinity, left, negative infinity. Right, positive infinity, left, negative infinity. Right, positive infinity, left, negative infinity. Okay, these all look very similar. They're all a little bit different though, okay? They're all a little different, okay? Okay, so again, I would not move on until you kind of have this down well. You might want to watch this video part 2 or 3 times, okay? All right, so let's actually hit some of these questions, okay? Number 17. And again, the good news is there's only 17, 19, only 3 questions like this, okay? And there's going to be questions like this on your next test, okay? I will tell you this. Not a bunch, but there will be some, okay? Number 17. So let's make this simpler. H of x is what? Negative 5x4. Negative 5x4 plus 7x3. 7x3. 6x squared. It's 9x plus 2. Okay. So they want the end behavior, okay? Now, all that matters is this one, because it's in standard form, so that's all we care about. This is our $20 bills. These are 10s, 5s, and change, 1s and change. We don't care about those. I mean, it makes an impact, but that makes the biggest impact is right here, okay? So what we care about is this, okay? So we look at our lead term. Is it an even degree? Yes, it is. It's an even degree. Lead coefficient is negative. So it's going to look like this. It's generally going to look like this, like a parabola, kind of like this. Now it's going to look exactly like that. It might look like this, okay? Which is generally a parabola, except for this funky part there in the middle, okay? So it's going to look like this, okay? So we're going to be clicking and dragging this right here. F of x negative infinity to infinity, f of x negative infinity to negative infinity. So that's what you need to click on, okay? You're going to put down this one right here. Negative infinity, infinity. So negative, positive, negative, negative. Okay? All right, next one, number 19. Okay. Number 19. I'm not going to write all, well, I will, what the heck, it doesn't really matter. Okay, it says f of x is negative 2x4. 2x4 plus 12x to the 8th, is that what that says? 12x8 plus 17. 17 plus 15x squared. This is not written in standard form, okay? If it was, this one would have been written first because that's the highest exponent. That's all we care about is 12x to the 8th. 12x to the 8th, okay? So, is it even degree? Yes, it is. 8 is even, okay? Lead coefficient is positive? Yes, it is. It's 12. It's going to look sort of like a parabola, sort of like this. So, you're going to click on infinity to infinity, infinity to negative infinity. So, positive, 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 negative, okay? And that's it. Okay, let's go to 21. Okay, they give us a very rough graph. Okay, and it looks sort of like, what's it do? Goes up and then down. Looks sort of like that, okay? So, they want to know, what could you say about the degree and the lead coefficient? Well, does it look like case 1, 2, 3, or 4? Well, it can't look like these. These are parabolas. That's not a parabola. Parabola both go up or both go down. This goes up and this goes down. So it's one of these two, and it's got to be this one because as to the left it's going up, to the right it's going down. It looks sort of like this one, okay? So in this case, it would be odd degree, lead coefficient's negative, okay? So in 21, it's odd degree, negative, lead coefficient. Okay, questions on that? Of course, no questions. Nobody's here. I'm by myself. That was stupid. Okay, so if you do have questions, though, email me, and I'll get back with you as soon as I can. Again, make sure you read your emails, guys, okay? Stay up with this stuff. This assignment is due, let's see, this is supposed to be started on Monday, January 1st. It's due Wednesday, January 6th at 3 o'clock. Again, if you have questions, email me, and try to keep in touch, okay? All right, talk to you later.